Hi Digu Science friends, learning is the key to opening the door to success. Make every lesson an opportunity to grow and develop. A mercury barometer shows a certain number. Now we are asked to calculate the atmospheric pressure around the barometer. One important concept in static fluids is that the pressure of a point in the same fluid, and the same height is the same. In the following YouTube, we can draw a straight line through the fluid boundary. There are points 1 and 2. Both points must be at the same height, because both points are passed by a horizontal line. Points 1 and 2 also touch the same fluid. So the pressure at point 1 is the same as the pressure at point 2. P1 is the same as P2. We will apply this concept to answer our questions. There we see the height of the mercury in the closed tube, the density of mercury, and the acceleration of gravity. The barometer was first discovered by Evangelista Torricelli. We will learn to calculate the pressure read by the barometer. What does a barometer look like? A vessel containing a certain amount of mercury. The open end of the tube is dipped into mercury in the vessel. Inside the small tube there is still a column of air. Imagine the air in the tube is pumped out until the tube is vacuumed. The height of the mercury column in the small tube will increase until it reaches a certain point. In that question, the height of the mercury in the barometer is 75.6 centimeters. How do we calculate atmospheric pressure using a barometer? Simple, just draw a horizontal line through the surface of the mercury. Place point 1 on the surface of the mercury that borders the outside air, and point 2 on the mercury that is in the small tube. Points 1 and 2 touch the mercury and are at the same height. Automatically, P1 is the same as P2. Now we will calculate the pressure value at both points. Above point 1 there is only atmospheric air, meaning point 1 gets atmospheric pressure. Above point 2 there is a column of mercury, and a vacuum column. Both columns will provide hydrostatic pressure and zero pressure. A vacuum does not exert pressure on anything, because there are no particles at all. So the value of atmospheric pressure is ρgh. The density of mercury is 13,600 kilograms per cubic meter. The acceleration due to gravity is 9.81 meters per second squared. And the height of mercury is 0.756 meters. This calculation is quite easy, 100,862.5 pascals. This is the atmospheric pressure where the barometer is located. Happy learning, everyone.
I feel this pain, you already know. Turn that to gains, let my money show. I've got these things that I can't let go. Watch me turn this life into something that you can never own.